All right. Hey, today we're going to talk about what in the heck is a cognitive process in this course designed for understanding the computational models of cognitive processing. It's important to get a good grasp of what we actually mean by either of those terms. So, let's get into it. The common sense definition of a lot of so I say cognitive process to you, and what comes out? Probably something at this highest level, right? We in general, we kind of think cognition is thinking. What is thinking exactly? Oh, okay, well, we get into some mental stuff here. Thinking, reasoning, knowing, remembering, judging, problem solving. If they show evaluating in this little image I nipped from Google. So it's these very broad ideas, right? None of them are very well defined here, right? And they kind of overlap. They're pretty squishy when you think about it. Remembering clearly has something to do with memory, but so then does knowing, and probably most of thinking technically involves memory, right? Judging involves comparing ideas across different spectra. Like problem solving is this really complex thing we do that is that's pretty broad, right? So this is not sufficient. It's just like a nice shorthand for how we talk about it day to day. Getting a little deeper, we get into sort of cognitive abilities, right? The kind of things that we know the brain is capable of, and a little bit more separated into sort of specialty functions, right? We have perception, how we take in the world from outside. We have attention, like what are we actually focusing on at any given second, both external and internal. We have memory, so we have like working memory, short-term memory, long-term memory, all these things that you've likely encountered by now. Decision making, how do comparing ideas work at sort of this neurological level? Action, moving my hands around, talking, moving my body, right? A little bit in response to the music. I can't help it. So this is the idea of trying to get beyond just the surface level of understanding what cognition is and into something a little more, processy, right? That's the goal here, to understand process. So this is an upgrade, right? This is like sort of the moving parts of cognition. But it's still kind of shallow for understanding the process, right? It's not showing how they connect or how they interact together or what kind of like actions they do with each other. It's, these are defining the processes by what they achieve. We're capable of perception. We're capable of attention. Great. Doesn't really illuminate the process yet, does it? And structure, right? That matters too. So the process isn't just what it achieves, that's also how it does it, right? I'm not just here to eat the sandwich. I kind of need to know how it was made if I'm going to trust the sandwich, I guess, is a good way of putting that. So, yeah, and over here we have some more cognitive skills, using working memory, context recall, that kind of stuff. These are a little bit deeper, which is nice, but still, end of the day, this still isn't the full process, right? These are just sort of species of thinking, different kinds of information transformations that we encounter throughout the process of thought, right? So in a sense, we're kind of drilling down, and we're going to drill down even further in this course. But we kind of need to take a little detour real quick, because these ideas are not really complete either. There's still a lot of debate on what we should be calling cognition itself. The older definitions focus on like these specific things, observed cognitive processes in the forebrain. Like decision making seems to only happen in this area, so that must be where cognition lives. But this falls completely flat. It's over, right? That conception of what cognition is pretty much done. We've moved on to more elaborate conceptualizations. So why have we moved forward with this? Well, this doesn't leave us with a lot of wiggle room for understanding, is cognition human or is it more universal? Some folks argue that human is the only one capable of cognition. It's a little absurd if you think about beyond the surface level. Uh, but hey, I'm not here to totally throw my predecessors in the history, the giants on whose backs I stand, under the bus, just to remind everybody that science moves on. Science moves forward. Paradigms shift. So, is cognition uniquely human? Or is it more universal? Is it brain-centric? Or does it exist elsewhere in the body or beyond the body? If cognition goes beyond ourselves, where do we draw that line on things that are or are not conscious? Ooh, sticky territory. And is cognition a fixed set of processes that we've kind of illuminated, in the nice little boxes? Or is it a more fluid and dynamic thing that's definable at sort of a more granular core level? I think yes, and we will use that as we go through. But let's talk about some of these ideas real quick. Is walking cognitive? It's easy to look at that and think, well, I don't have to think about it, therefore it's probably not very cognitive. But think about this. How many neurons have to be active in every part of your body for you to walk forward? For you to take even one step without falling on your face? That's not really involving central. You don't have to actively think about every one of these things, right? You just have to move with it. So synergies between all of your muscular neurons are constantly in tension with each other, and they connect. They perform these complex transformations of information. Think linear algebra. Think huge matrices of like how much of information in this muscle's neurons are moving in what way to make the muscle move. Just so. Are you seeing that? Yeah. Okay. Had to check the camera. Even further. So, and also a lot of these things happen without ever sending like a true strong message up to the brain. It's just information processing that happens throughout the body. And it's part of what we are as an organism. Another thought here that kind of connects to this is your stomach and your heart both have brains, right? They have little bundles of neurons that do various things like signal satiety. So when you're done eating, by the way, that one's super slow. If you're having trouble pacing yourself eating, take a little time between, portions, and your stomach might eventually catch up and say, oh, hey, we're done. I have to deal with this a lot. The one in your heart does things like heart rate and angiotensin. So like how does my heart, how hard does it need to pump right now? How tight should the walls be, right? Furthermore, your eyes do this really cool stuff where even before the signals that come in on your retina, even before they leave the eyeball itself, they're already getting chopped into edge detectors and signals and borders and things like that on their way up to the brain, right? The brain doesn't just receive a full carbon copy photograph of whatever you're looking at and then, ta-da, we're done. So this is just sort of all to say a lot of what we think of as actions that we can take and perceptions that we can have of the world are, strictly speaking, complex information transformation by and large. But we also, so thus they might need to be incorporated in our view of what cognition is. Keep going. So this is embodied cognition. Cognition is sometimes this, like, we think of it as the stuff that happens in the brain in its very top-down sense, right? It's certainly a necessary inclusion. The things that happen in the brain are clearly cognitive. That's sort of the base definition we've been operating on for years. But it's not sufficient for explaining all of the interesting information transformation that happens in the body, and more critically, between all of these things, right? The body is doing its own thing, but the body is also having synergies with, your brainstem and all throughout your up brain, that you're also having all these connective things happening all throughout. So the more accurate take is some processing is distributed throughout the body. This is embodied cognition. And so it's not just things coming from central up here, it's also happening throughout. And it's this deeply complex network of informed neighboring systems, all sending information back and forth all the time in crazy detail, right? The brain proper is only involved in a portion of that. So you see how this sort of confronts the question of, well, wait, where does cognition stop? And the answer is, that's not super clear, everybody. In fact, I would say there's far more evidence these days for it being distributed. We can go even further with this. Have you heard of extended cognition? What would happen to your ability to answer questions and remember appointments or phone numbers right now if I stole your phone? Think about that for a moment. Probably not a happy thought. Imagine navigating your day tomorrow and your phone is just gone. The answer is obviously that you'd figure out a way to get by. But think about how complex and annoying everything would become. You have to plan your day around trips to the library to hit the right computer, whatever. This thing is clearly incorporated into your thinking system, right? So this is more debatable, but it's still, I think it's very interesting. Even our tools, some say, should factor into how we consider cognition, right? After all, if my hands and eyes possess some distributed cognitive capabilities, right, as in embodied cognition, then what happens if we point them both at a phone, right? In extended cognition, the phone becomes temporarily part of our cognitive system, right? So this is extended cognition. The phone is part of it. It's effectively connected to our fingers and eyes. We are sending commands with the thumbs and mostly the thumbs, I guess. But it's also giving us symbols back to our eyes. We are pushing motor actions into the world in order to get new symbols that we can then operate on up here. Get it? So take this whole thing as a shared system, and it vastly extends our cognitive capabilities beyond just what's living in our brains and our meat, right? So this little thing I whipped up on the side here, your mind, your cognitive system can interface directly with a phone. And by doing that, this shared bit of like where our eyes and our phones meet, our hands too, the phone has its own processes going on, but it can reach out to the internet and get you all kinds of information that can come back through the system back to your mind. Taken as a whole, if we include the phone in our cognitive system, we start to open up the idea of, okay, what am I when I have access to something like the internet, compared to what am I when I have no access to the internet? Wait. Okay, keep going. So there's still more debatable bits to get into. Animals exhibit lots of the same processes we do. We are, after all, just mammals, right? They evolved differently than we did, but we have overlap. For example, foveal vision, that is the focused center point that we receive highly detailed information from, so that, the middle of your vision, right? It exists in a ton of species, not all species. Some species need almost no foveal vision, like prey animals, like goats and deer. They don't need super high detailed acuity because mostly what they're eating is like leaves and looking out for being killed, right? They just need the broad, fast detectors that are non-foveal. But these foveal ideas exist in a ton of species, and these days some artificial systems even adopt the same pattern. So let's look at just it's a little blurry in its own right. I snipped a somewhat blurry image, but you see the idea here. It's very broad and blurry at the edges, but some of us have this capacity to get sharply detailed centroid vision, right? It's about, if you've never done this before, it's about take your two thumbs at arm's length and look between them. That's about your foveal vision. You can just do that whenever you want. So this idea of multiple realizability is where this sort of comes to roost philosophically. The same cognitive processes can be realized in different ways, right? Vision exists in humans, cats, flies, octopi, phones, and computers, right? Some are more biological, some are more synthetic. All implement a similar capacity to turn light patterns on sensors into something else more useful further downstream in the process of vision. So it's kind of hard to shake this idea once you start thinking about it. It means that, it's not just uniquely human to have cognition. It really undercuts that. So the question being, if we're going to challenge this, if cats have some of the same parts that we do, they have the same kind of like types of foveal vision, although theirs is a little different by and large, they still have the same part. Why are we cutting them out of the discussion? If we want to think that cognition is uniquely human. Further extend this conversation to like octopi and bees or computers. I'm not saying all computers are cognitive entities, but I am saying that the distinction is a lot fuzzier than history has tended to indicate up until now. So, coming out of these debating topics, the failings of this focus on this like strict definition of like what is cognition is the same as it always is in science. It's that nothing in nature is actually discrete categories or binary, like, oh, it's this or it's not this. That's just a simplification that we make up to make things a little more bearable. There is nothing delineating the left lane from the right lane in physics of a car, of a road. There is only, I think I'm in the right place versus I think I might be in the wrong place. We need that information. The road doesn't care, right? I know that there's a line down the middle, but the point is that that's all just kind of particles floating around, right? So everything is not discrete. Everything is a lot more continuous and fuzzy. Things come from these overlapping distributions. There's always exceptions to every categorical line we draw. So, therefore, thank you, history. We have identified that cognition exists. And that's always the first step in science, is detection. Is a thing there or is it not? The next step, because things are not binary like that, ever, the next step is to measure it. Not just throw a big tarp over it and say, this is the cognitive stuff and this isn't, right? So, in effect, it's a lot more useful and interesting to define cognition not as a binary category of yes, you are cognitive or no, you are not, but rather on a gradient of complexity, right? You have things that are simple, that do simple cognitive processes, and you have things that are more complex, like us, and things that are maybe more complex than us. So here's where the sort of, I'm adopting this stance for the course, and this is where sort of the criticism can start to filter in. Hey man, are you saying that thermostats are cognitive? And my answer is a little, yeah, on this most basic level. What does a thermostat do? It perceives a signal. It decodes it in some way. It converts it into the action of sending power to the heater or the AC, right? Its cognitive capacity is not complex. It does kind of one or two things, depending on how you count it, but it exists, right? It's sitting there making small decisions, changing information in very small ways, and it really affects your house, right? So consider this alternative, the counterpoint. It's actually more reductive to decide there is one giant blanket category of what qualifies as cognition, and then spend most of a century arguing over where to draw those lines. I know I sound a little saucy, but it's accurate. I mean, we've been laboring under this idea that cognition needs these rigid definitions when there's kind of no point. And I think as we go through this course, you're going to start to see that. So, the operational definition of cognition for this course is that cognition is the transformation of information. In cognitive science, thus is sort of the study of informational entities, things that are built around information transformation, things that perform information transformation, things that are sort of informational in nature. I would say you are informational in nature. Most of what makes you, although that includes the information in your body, recall. So, these informational entities are situated on a spectrum of complexity, right? We have the thermostat at the far end that we just discussed, right? And, you can keep going up. Mollusks are a little more complex than a thermostat, though not much if you've had brains, minds, consciousness. Bees are more complex than that. Cats, And in fact, bees and cats are actually closer. It's wild. Humans, we know we're super complicated. Yay! Then we get supercomputers. Okay, there's a lot of data moving around those. They might be more complex than us. The whole internet, the whole universe, we have a far spectrum here. And all of these entities, the thing that makes something, informational entity is that it's composed of countless processes. Well, I say countless. Some of them are countable, very. The thermostat, for example, is a very countable process. And the shapes that the information takes as it is transformed and transmitted into that system, throughout that system, and out of that system being cognitive systems. So the focus in this course remains on our most advanced and well-studied informational entity, us, but others are still welcome, and you'll see that as we get into the sort of artificial side of things. So, what's the big deal? What's the point? Well, the course is about modeling cognitive processes, but really what this does for us, what this definition I've provided does for us, it says, okay, if our focus is on the transformation of information in whatever form that might take, then we can capture those transformations of processes, of information, right? When the image comes into the eyeball, it gets processed into edges, and then those edges get processed into shapes and patterns, and then they're recognizable. We're able to look at each step in a way, in an information-focused way, and say, what's changing here? What is this process? How is it doing it? Neurologically in humans, but other ways in other entities, right? So, and because that is a truth, right? Because that's a capacity we have here, we can build models and simulations of these processes, right? We can both use them to learn more about ourselves and to build other entities that use some of the same modeled capabilities that we find in ourselves, right? So thinking like decision trees, machine vision tools, Midjourney, ChatGPT, whatever comes next, man, it's all coming fast. Pay attention. So there's a recap. We have a common sense notion of what cognition is, broadly, right? But we need to go deeper than that to understand it as a process. And there's plenty of debate about what precisely constitutes that cognition as a conceptual term. In this course, we land on this operational definition of cognition as the transformation of information, with this focus on us as the best example, but room to discuss any others that come up. Make sense? So, that's cognition, and that's cognitive processes, at least as far as this course considers them. More soon.